Hi guys, welcome to another one of DOWLATH revision series lectures, and this is number 8 where we'll be looking at the gas laws. Now before we get into a typical application like question, let's revise a little bit about the law itself. Now gas laws, there are 3 kinds, and all of them relate the behavior of a gas according to 3 parameters, which will be pressure, volume, and temperature. So in the first law, which is Charles's law, we are saying that volume is proportional to the absolute temperature for a fixed mass of gas, provided that the pressure remains constant. In the pressure law, we are saying for a fixed mass of gas, the pressure is directly proportional to the absolute or thermodynamic temperature, provided that the volume is constant. And for Boyle's law, we are saying for a fixed mass of gas, the pressure is inversely proportional to the volume, provided the temperature is constant. So if I were to combine mathematically what each of these 3 laws are trying to illustrate, I will come up with a general equation. Now many times in your exam they will ask you for 1 mark to state the general gas law equation, and they will ask you to define the variables. So we can illustrate it like this. P1 V1 on T1 is P2 V2 on T2. So you will find that P1 is the initial pressure, P2 is the final pressure, V1 is the initial volume, V2 is the final volume, T1 is the initial temperature, T2 is the final temperature. So what we are looking at is a gas having an initial range of properties according to pressure, volume, and temperature. Then something happens to the gas, it's compressed, it's heated, it's allowed to expand. So something happens to it, and you have these conditions now having a change in value. And hence you will have P2, V2, and T2. Now I gave you a question, and it's a little bit application based. So as I normally illustrate how I do a question is that I will start off by breaking up the question, apple picking, pulling out the pieces of information. All right, so let's go. Consider a gas of volume 2 meter cube. All right, so once you reach the variable, you start to label it on top, V1, having a pressure P. So P would illustrate P1 at room temperature 27. So we're going to convert him to Kelvin 1 time, because I don't want, and this is a common error that students make, is that they take the temperature in degrees Celsius, right? And they need to convert it to Kelvin. They don't convert it to Kelvin, but you need to according to this formula. It is heated to 3 times the volume. So V2 is 3 times V1 at a new temperature of 150. So T2 will just be 150 plus 273. Determine the percentage decrease in pressure. So clearly they are telling you, they're helping you, where they have indicated that your P2 is less than your P1. Right? So they would have indicated that here. All right, so the first thing we do is we always list our variables. So I have done that, and I have also shown the calculation where I have converted my temperatures into Kelvin. Okay? All right, next you then substitute. You have P1 and P2. Then you substitute the variables, and you find P2. Now P2, because I did not have an initial value for P1, is given in terms of P1, which is P, and you've clearly noticed that it is less than P, because the value of P2 is 0.47 of P. Now they want to know the decrease, the change in pressure. So we always consider in physics a change to be the final minus the initial. Right? So when I worked it down, I subtracted it and I got a negative sign. Now the negative sign is indicating that, okay, it is a decrease in pressure, right? So because I was already told in the question that there is a percentage decrease, I'm just using the modulus of the value. The modulus means I'm not considering the negative sign, because I've already understood that the percentage value I am calculating is a decrease, it's a deficit value. So here I work out and I get delta P, the change in pressure over pressure by 100. So it works out to be the change in P, which is expressed as 0.53 over the initial value P by 100. So now I'm able to identify that P2 has decreased by 53% from P1. Okay, so join me for my next lecture tomorrow, where I will be looking at it's a surprise, so join me tomorrow.